the laws of chemical combination. The laws of chemical combination. Chemical combination. First law is the law of conservation of mass. Conservation of mass. This law was introduced by A.L. Lavoisier. A.L. Lavoisier. See, A.L. Lavoisier is considered as the father of modern chemistry. The law of conservation of mass states that during a chemical reaction, the total mass of the reactants is equal to the total mass of the products. That is, mass can neither be created nor be destroyed during a chemical reaction. Consider the example. See, carbon burns in oxygen forming carbon dioxide. Carbon burns in oxygen forming carbon dioxide. The atomic mass of carbon is 12, so carbon 12 gram. Atomic mass of oxygen is 16. 16 into 2 is equal to 32. And for carbon dioxide it is 44. Carbon 12, oxygen 32, that is 44. So 44 grams. Here the total mass of the reactants, the total mass of the reactants is equal to 44 grams, and the total mass of the products, is also 44 grams. That is, mass of the reactants is equal to the mass of the products. Mass is not destroyed here. That is what is the law. So, the law of conservation of mass was introduced by A.L. Lavoisier. The law states that during a chemical reaction, the total mass of the reactants is equal to the total mass of the products. That is, mass can neither be created nor be destroyed during a chemical reaction. For example, carbon burns in oxygen forming carbon dioxide. Write down this equation. Here, the total mass of the reactants is equal to 44 grams and the total mass of the products is equal to 44 grams. Hence, the law is explained or illustrated. Now, let us take another example. Say C, carbon burns partially in oxygen forming carbon monoxide. C plus O2 gives CO. You know, this equation is not balanced. Previously, this equation was balanced. Carbon 1, oxygen 2, oxygen 2. But here, the equation is not balanced. Now, let us check 12 gram carbon. Oxygen 16 into 2 is equal to 32. So, the total is 44 grams. And carbon 12 grams, oxygen 16 is equal to 28 grams. See, in this unbalanced equation, the total mass of the reactants is 44 grams and the total mass of the products is 28 grams. They are not equal. So, this is against the law of conservation of mass. Why? Because mass is not conserved. Here, mass is lost here when the product is formed. So, let us check another way. Check in another way. See, I am going to balance this equation. The balanced equation is this. C plus O2 gives 2CO. Here, there are 2 carbon atoms on reactant side and there are 2 carbon atoms on product side. There are 2 oxygen atoms on reactant side and there are 2 oxygen atoms on product side. Okay, the equation is balanced. Now, let us check the masses on both sides. See, for 2 carbon atoms, it is 12 into 2 is equal to 24. For 2 oxygen atoms, it is 32. So, 6, 56. Total mass of the reactants is 56 in the balanced equation. Here, in the case of carbon monoxide, see, carbon 12. 12 plus oxygen 16 is equal to 28. See, therefore 28 into 2, there are 2 molecules of carbon monoxide, that is 56 grams. So, the total mass of the products is 56 grams and the total mass of the reactants is also 56 grams. Now, the law of conservation of mass is obeyed. Now, the second law is the law of reciprocal proportions. Reciprocal proportions. See, this law was introduced by J.B. Richter, R-I-T-C-H-E-R, J.B. Richter. The law states that of the three elements, A, B and C, if A combines with B in the ratio X is to Y, if A combines with C in the ratio X is to Z, then if B combines with C, they will do so. They will do so means, see, for B it is Y and for C it is Z. So, B and C will combine together in the ratio Y is to Z or a simple multiple of Y is to Z. That will be revealed by explaining an example. Okay, I am going to give you an example. See, carbon, hydrogen and sulfur are the 3 common elements. Carbon combines with a hydrogen forming methane in the ratio 12 is to 4. You know, carbon is to hydrogen in the ratio 12 is to 4 by mass. Now, carbon combines with the sulfur forming carbon disulfide in the ratio 12 is to, see, atomic mass of sulfur is 32. 32 into 2 is equal to 64. So, 12 is to 64. Then, if hydrogen combines with the sulfur forming hydrogen sulfide H2S, then the expected ratio is 4 is to 64. Am I right? Expected ratio is 4 is to 64. But the correct ratio is 2 is to 32. You know that 2 is to 32 is a simple multiple of 4 is to 64. That is, dividing 4 is to 64 by 2, we get 2 is to 32. So, 2 is to 32 is a simple multiple of 4 is to 64. Hence, the law is correct. So, the law of reciprocal proportions states that of the 3 elements A, B and C, if A combines with B in the ratio X is to Y, if A combines with C in the ratio X is to Z, see, this is 1, this is 2, then if B combines with C, they will do so. They will do so means they will reciprocate. Okay, that is what is called reciprocate. They will reciprocate. So, they will do so either in the ratio Y is to Z or a simple multiple of it. That is what is the law. Now, illustration. See, carbon, hydrogen and sulfur are the 3 elements. Carbon combines with hydrogen forming methane in the ratio 12 is to 4. Now, first and second. Now, first and third. Carbon combines with the sulfur forming carbon disulfide in the ratio 12 is to 64. Okay. Then, if hydrogen combines with the sulfur forming hydrogen sulfide, they will be in the ratio 2 is to 32, which is a simple multiple of 4 is to 64. Okay. The law of constant proportions or definite proportions. Law of constant or definite proportions. It was introduced by J.L. Proust. J.L. Proust. The law of definite proportions states that pure samples of the same compound always contain the same elements that are combined together in definite proportions by mass. See, let us take an example. 2 samples of common salt or table salt or rock salt obtained from 1. A salt mine in Pakistan. Salt mine in Pakistan. And the second sample obtained from Indian Ocean. Obtained by evaporating seawater, Indian Ocean. See, this is sodium chloride. It contains sodium and chlorine in the ratio 23:35.5 by mass. Similarly, this sample also contains sodium and chlorine that are combined together in the ratio 23:35.5. See, these 2 samples are in agreement with the law of constant or definite proportions. Pure samples of the same compound, pure samples of sodium chloride, obtained 1 from a salt mine in Pakistan and 2 from Indian Ocean, were found to contain sodium and chlorine that are combined together in the ratio 23:35.5. Hence, the law is correct. Let us take another example. See, water. A sample of water obtained from a well in Kerala. It contains hydrogen and oxygen in the ratio 2:16. See, another sample of water obtained from a bore well in Rajasthan. It also contains hydrogen and oxygen in the ratio 2:16 by mass. Let us check another sample of water obtained by melting ice, a piece of ice obtained from Kashmir Valley. See, it also contains hydrogen and oxygen in the ratio 2:16. Take another sample of water obtained by burning hydrogen in oxygen in a fuel cell. What is a fuel cell? Fuel cell is a cell used for producing electricity by burning fuels like hydrogen. We will see it. This type of fuel cell was used at first in Apollo space program. See, if hydrogen is burnt in oxygen to get water, then also water contains hydrogen and oxygen in the ratio 2:16. See, I have taken different samples of the same compound and they are pure and they contain hydrogen and oxygen in the ratio 2:16 by mass. Hence, the law of constant or definite proportions is illustrated or verified. So, the law of constant or definite proportions states that pure samples of the same compound always contain the same elements that are combined together in definite or constant proportions by mass. That's all. The fourth law, the law of multiple proportions. The law of multiple proportions. This law was introduced by John Dalton. John Dalton. The law was introduced by John Dalton. Consider an example. See, C and O are two elements. Carbon burns partially in oxygen, forming carbon monoxide. Here, carbon and oxygen are in the ratio 12:16. Carbon burns in oxygen, forming carbon dioxide, another compound. Here, carbon and oxygen are in the ratio 12:32. That is 16 into 2 is equal to 32. In these compounds, the masses of carbon are the same, but the masses of oxygen are different. The different masses of oxygen, that is 16 and 32, that combine with the fixed mass of carbon, that is 12 gram, bears a simple ratio 16:32. The different masses of oxygen that combine with the fixed mass of carbon bears a simple ratio 16:32 or 1:2. This is the basis of the law of multiple proportions. So, the law of multiple proportions states that when two elements combine together to form more than one compounds, the different masses of one of the elements that combine with the fixed mass of the other bear a simple ratio. Here, carbon has the same mass, but oxygen has different masses. The different masses of oxygen that combine with the fixed mass of carbon bear a simple ratio 16:32 or 1:2. Let us see another example. A and B are two elements. They combine together to form three compounds: AB, A2B and A3B. See, three compounds are formed from A and B. They are these. Here, the mass of B in all these three compounds are the same, but the masses of A are different. The masses of A that combine with the fixed mass of B are in the ratio 1:2:3. The masses of A that combine with the fixed mass of B among these three compounds are in the ratio 1:2:3. Hence, the law of multiple proportions is explained or illustrated. Fifth law, Gay Lussac's law of combining odiums. Gay Lussac's law of combining odiums. Law of combining odiums. Combining odiums. See, this law is also called the law of combining odiums. Gay Lussac's law of combining odiums or the law of combining odiums. See, I'm going to give you an example for the law. See, hydrogen combines with the chlorine forming hydrogen chloride. See, balancing this equation, H2 plus Cl2 gives 2 HCl. Here 2 hydrogen atoms, chlorine 2 here, chlorine 2 here. Here, the volume of hydrogen. What is the volume of hydrogen? The coefficient of hydrogen. H2 means 1 H2. The coefficient is 1. So, 1 volume of hydrogen. See, what is Cl2? Cl2 has the coefficient 1. So, 1 volume of chlorine gives the coefficient of HCl is 2. So, 2 volumes of hydrogen chloride. See, all these are gases. Hydrogen is a gas, chlorine is a gas, and HCl is also a gas. According to Gay Lussac's law, the volumes of gaseous reactants, that is, what are gaseous reactants? Hydrogen and chlorine, they are gaseous reactants. Gaseous reactants. reactants in gaseous state. And the volume of gaseous products. Gaseous product is HCl. And these volumes bear a simple ratio 1:1:2 under the same conditions of pressure and temperature. Same conditions of pressure and temperatures. That is, their volume must be measured at the same temperature and pressure. Okay. So, Gay Lussac's law of combining volumes states that volumes of gaseous reactants and gaseous products bear a simple ratio under the same conditions of temperature and pressure. They must be the same. If they are measured under different temperature and pressure, the law is not valid. If they are not gases, all the reactants and products must be gases. If they are not gases, the law is not valid. See, let us check an example. See, A. CO3 gives CaO plus CO2. See, calcium carbonate solid, calcium oxide solid, and carbon dioxide is a gas. See, another example is magnesium carbonate gives MgO plus CO2. See, magnesium carbonate is a solid, magnesium oxide is a solid, and carbon dioxide is a gas. Now, hydrogen plus nitrogen gives ammonia. See, N2 plus 3S2 gives N2 plus 3S2, or 3S2 plus N2 gives 2NS3 ammonia. Here, hydrogen is a gas, nitrogen is a gas, and ammonia is a gas under the same conditions of temperature and pressure. See, the first, that is, A choice is not according to Gay Lussac's law of combining volumes, because calcium carbonate and calcium oxide are solids. Second example, that is B choice, is against the law, Gay Lussac's law of combining volumes. It is because magnesium carbonate and magnesium oxide are solids. Only carbon dioxide is a gas. But C choice is correct answer. Why? Because here reactions and products are gases. So Gay Lussac's law of combining volumes is obeyed. So the law is valid only when all the reactants and products are gases, and their volumes must be measured under the same conditions of temperature and pressure. Okay, that is what is called Gay Lussac's law of combining volumes, or the law of combining volumes. Avogadro's hypothesis. Avogadro's hypothesis states that equal volumes of all gases under the same conditions of temperature and pressure contain the same number of molecules or number of particles. See, I have taken 3 vessels of 1 liter odium. See, 1 liter carbon monoxide is taken in the first vessel, 1 liter hydrogen is taken in the second vessel, and 1 liter oxygen is taken in the third vessel. If the volumes of these gases are measured under the same conditions of temperature and pressure, then all these gases contain the same number of molecules. This is what is called Avogadro's hypothesis. Avogadro observed that 1 mole of any gas at STP contain 6.022 into 10 raised to 23 molecules. and this number is called Avogadro's number, N, that we have already learned. See, this number is called Avogadro's number. So, Avogadro's hypothesis states that equal volumes of all gases under the same conditions of temperature and pressure contain the same number of molecules.